Hello everyone, welcome back to another episode of creating a super simple first-person controller. In the Unity physics samples, there is a character controller scene which is controlling a third-person perspective character. And what I would like to show you in this episode is that how the input is handling in this project. First, I would like to show you what this third person character can do for us. So if I move the mouse up and down, technically this moves the gun up and down. If I move the mouse left and right, it turns the character around. And the WASD key is move the character around. This is like a very complex scene because the character can go on top of platforms and slopes and stairs and stuff like that. And also with a bit of luck, I can travel on platforms like this, or actually, let's just go off here. There is like an elevator thing. I can jump with a space key. Oh, I could just step on it so I can go up and down with this elevator thing. And I can fall obviously, and I can go all over the place. In this I can climb mountains. I can actually kick away things. So come on, let's get inside here. So this got these weird shapes that I can climb to. So this is overall even though this is a third person perspective character, still can be a good source of information of how does one create a first person character. So let's see what's going on. So in this scene, and the scene is in fact can be found in the demos. So let's just first show me the repository. So we've got this entity component system samples. This is at the 0.17 version of the entities. It hasn't been updated yet to the 0.50 version. And there is this Unity physics samples, and within that, in the demos part, there is this use cases section which contains a character controller. So one part can be found here, but there is one important other part, and that is the input handling. So the input actions itself and the generated class can be found in the common directory, and there is a demo input gathering system for communicating the input, which is the non-dots input, because this uses the new input system, to a dots data to process for the dots systems. And in this video, this is what I would like to focus on primarily, how this input is gathered. So let's take a look at this input action. So the move is the left stick gamepad, the WASD key, and also the look is the right stick and the delta mouse that is used the rotating left and right, and the gun. And also there is a fire button and also a space for the jumping. And also it has a generated class. Let me just show you that. which contains all sort of method. This is the standard automatically generated class that one can call in the code for these various actions. You can like define custom functions or delegates for these methods. And also let's check what is attached to this character. So this is basically is a capsule, and it has a character controller authoring. We are going to take a look at that script in a moment. It has a capsule physics shape, and what is important to note is the collision response is set to none. We are going to get back to this later, and the physics body is kinematic. And pretty much that's it. It contains camera position and a gun. Also in the physics scene basic element there is a main camera, and the camera's position, it in this project it doesn't uses the cine machine. It handled specifically with some script, which I'm not going to take a look at in this tutorial series or in this creating simple first-person character controller. But if you guys want me to take a look at those codes, please let me know in the comments below. I think that's it. Let's take a look at now this character controller authoring script. What does it do? So first of all, we've got a character controller component data, a character controller input, and the character controller internal data. And this character controller authoring going to attach a character controller component data and a character controller internal data. If the collision event has to be raised, this uses since the collision has set to be none in the physics shape. So the collisions and trigger responses has to be calculated manually. There is this can be indicated with this raise collision events and raise trigger events flags. So if the collision events has to be raised, then it creates a stateful collision events. The stateful collision event exists only in the Unity physics samples. Basically, these are collision events that has an on enter, on doing, on happening or something, and on exit functionality, sort of. I'm not addressing those here, but yet again, if you want to know about more about that code, please let me know and I can create a video for you. And same stands for the stateful trigger event. This is similar to the stateful collision events, is just for triggers. And also this tag exclude from trigger event conversion. This is just a tag which helps to for, I guess, excluding from trigger event conversion. I don't recall exactly what this text for, but this is just a tag. So I created the diagram. So the character controller component data has this gravity, movement speed, max movement speed, rotation speed, Jonapar speed, max slope, max iteration, character mass, skin width, contact tolerance, effects, physics body, race, collision events, race, trigger events. There is only one component of these. This character controller internal data has a current rotation angle, a supported set, an unsupported velocity, a velocity entity, and is jumping, and the input fields. And this input field is in fact this character controller input type, but there is a character controller input as a singleton component as well. And also there is this exclude from trigger event conversion. Sorry, this is just one-to-one because there is at most one component from this component on the character, and there are one-to-many stateful trigger events and stateful collision events on this character. So this is what we got here. Now let's check how the input has been converted from the non-dots data to being a dots data. So I've already mentioned this character controller input. And basically we've got this demo input gathering system. This is yet again in the common assets, common folder. So this project, it includes the new input system by default. So it says that in order to prevent API breakages or something, they decided to put this in the Unity input system exists. I don't quite understand why, because as I mentioned already, the project contains the new input system, so it should work in my opinion, but they know it better. But anyway, in order to make it work, we should define in the scripting defined symbols the Unity input system exists, because in this way, this is the only way that this code is going to run with the new input system. Otherwise, it is not going to do anything and the character will not move. So this demo input gathering system inherits from system base and this I controller character and actions and I vehicle actions. We've got all sorts of member variables defined, and let's take a look at this on create. So we are going to create some new input actions and we are going to set the callbacks on this instance. So this input actions, it is going to be it contains the set callbacks, and it's going to get an instance parameter, and now it is going to set up this started, performed, cancelled, and so on, etc. Actions, callbacks, and same for the vehicle. And actually we are defining some entity queries which is works with dots. Character controller input will be the one of the entity query, the character gun input will be the other, and the vehicle input will be the third. And also we are going to set the on move, the on look, the on fire, and so on, etc. to make sure that we've got these m character movement member variable, and we are just going to read the values of these. And similar with the vehicle actions, but I'm not going to address the vehicle actions at all. So what happens on the on update? So basically we are going to create an entity with this character controller input, and we are going to set the singleton for this character looking member, which is obviously going to get updated on the on look, and the m character movement is going to update it on the on move, and the jump is going to be updated on the on jump input action. And we are going to store all of this data. If the character jump, then it is going to be 1 and 0 because the jump is an integer variable. And also we are going to uh, do something similar for the gun and similar for the vehicle input. So basically this calling this set singletons, we are going to update the character controller input to the corresponding value, and with this now we can query this character controller input and use this data for whatever we want. And in fact, there is this character controller one-to-many input system. So basically, as I mentioned before, this character controller internal data contains one input field, which is a character input component. And this one-to-many input system is searching for character controller internal data, and it copies the movement and the looking data and the jumped data to a singleton character. So gets this character controller input singleton value and copies the input to the character controller internal data. And in this way, the character controller scripts are going to process this character controller input point movement, looking, and jumped values. Now that we all know this, I think this will be the end of this video because I decided that I think I'm going to put out many shorter videos about this subject rather than one hyper super long video. So I decided that this will be the end of this video. I hope you enjoyed it and perhaps learned something from it. And in the next video, I'm going to show you how did I use something similar to my super simple character controller. But until then, goodbye.